Hey, what's up everybody? Welcome back to another 3D Hangout. My name is Noah West. I'm a designer here at Adafruit. Joining me every week is Mr. Pedro.
What's going on, everybody? Pedro West, Creative Tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right. This is a show we combine 3D printing and DIY electronics to make inspirational projects. What's up everybody? Welcome to episode 188, Crafting with Circuits. Let's do a quick rundown of what we're going to cover in today's show. 2 guides.
We got 2 guides this week, all paper craft.
That's right. We also have some MakeCode stuff. We're going to do a sneak peek at MakeCode with the CRICKIT board.
We're going to take a look at a quick way to make your alligator clips into male jumper compatible alligator clips.
Yep. We have a shiny, brand new 3D printed case for ItsyBitsy.
Don't worry, we are still 3D printing in the background.
Yeah. So we have a case for this guy, which is the Joy Featherwing. We also have an awesome guide for the ItsyBitsy. We got some new additions to our Adafruit CAD parts GitHub repo.
Bunch of Qriket inspired cardboard projects. Nice little playlist to go through.
That's right. With accompanying code on GitHub. There's also some awesome new guides that we're going to take a look at that have to do with the CRICKIT, where you're going to shout out to Dano. We're going to take a quick look at Dano's profile and a special project from a very special, cool education maker. All this and more on, you guessed it, let's run the intro. 3 Hangouts.
Excellent.
Good morning, everybody. Thank you all for joining 3D Hangouts.
Yeah, that was the intro. So we kind of went through the show. Let's go ahead and jump right into today's coupon code. This paper craft.
That's right. Paper craft will get you a 10% off your order. Works on everything except subscriptions and
Gift. It's hard to say that one. Gift certificates. If you go to adafruit.com/free, you can see all the cool deals that we have going on. Free circuit playgrounds and perma-protos and ground shipping, all that. Check out the details at adafruit.com/free. We also have some same-day delivery options for fine folks in the New York City area, so go to the websites for that. We have a Circuit Python cake that was very delicious. This is a picture of a cake.
So this show happens every Monday, except this week.
No, not this show.
No, Circuit Python.
There's a Circuit Python meeting that happens every Monday at 2 p.m. on the Discord server.
We've been playing too much servos. But it is on the audio channel for Discord. Check out Discord at discord.gg/Adafruit. If you go onto the left-hand side corner, scroll all the way down, you'll see the audio chat for that. Happens every Monday at 2 p.m. Definitely join in for that.
That's right. And real quick, I'm going to talk about some newsletters. Adafruitdaily.com. You can get a bunch of daily newsletters in different categories like CircuitPython, Maker Business, 3D printing, that sort of stuff. We also have a product-focused one, adafruit.com/newsletter. That happens once a week. Okay. All right, let's jump into this week's project. This week we have 2 paper craft projects. The first one, well, this is sort of the second one, right? This one was released today. So this is a template that it's made out of cardboard, and it can house a Circuit Playground Express, a 3 AAA battery, and a micro servo. Why am I losing my voice? This is a really cool template. It's sort of like a base starting point for folks that want to get started with crafty cardboard projects. So we figured we'd make a paper template that folks can print out on a regular office printer with an inkjet or a laser printer. Those are fairly common and readily accessible. This template fits on an 8 by 11 inch piece of paper, which is sort of your stock standard piece of paper. So you just cut out the parts and then lay them out on a piece of cardboard. Preferably the cardboard that ships with Amazon boxes or any of those shipping boxes works really well.
Of course, AdaBox
works as well. And the way this works is that it has these little slots in certain areas, and then other ones have these tabs that fit into those slots. So They have a little bit of tolerance so that they fit nice and tight together, which is pretty nice. And then there's some mounting points on the back there that I actually didn't make on this one, but if you show this one off, you can see the Circuit Playground already installed there using some brass standoffs in M3 hardware. The battery goes in between these two walls so you can quickly get to the battery, and the wires just kind of get tucked underneath. So this is what I figured out, is that you could stick a little blink ahead on the servo horn and then make her head kind of move, which is neat. And if we go over to learn.adafruit.com, which is on this tab, you can see the guide that talks about all the things. So the intro page just kind of walks you through what parts you need. There's no soldering required, so it's really simple and easy to kind of plug and play these things. And then some tools and supplies. We'll need some cardboard, some office paper, that sort of stuff, scissors, And then Circuit Playground, the Alligator Clips, which we're going to show you how to make your own, and the microservo and the battery. So really straightforward. So let's go ahead and walk through the MakeCode real quick. So MakeCode is a great way to get started into programming. It's a drag and drop code block based editor, which is from Microsoft. And right now we have support for the Circuit Playground Express. So you can play around with different inputs like sound, audio. You can play around with neopixels. You can play around with different tones because there's a speaker, a little buzzer speaker on the Circuit Playground. So what we have in this example, which is down here, lower down over here, we kind of walk you through the demo that we have. So basically what we're saying is, let me let this load. This is really cool because you can embed live demos into interactive demos into our learning guide, which is really nice. So we have a couple block elements here. We have a couple inputs. This first one is saying when we press button B, we want to set the servo to go to 90 degrees, and we want to show a certain amount of pixels. This is a really easy way to kind of get servos and neopixels working together, which is really nice. And then you have the ability to kind of change what type of click, whether you want it to be a long press, or if you want it to be on the up or the down state. And then we have a duplicate of that, but this time we're saying on button A, make the servo go to 10 degrees. And then we want to show these type of neopixels. So it's a very visual way to kind of understand what this thing is doing. And then the last block we have on shake, which we have it just show an animation, a rainbow animation on the neopixels for half of a second. And then we want to write to the neopixel, or we want to write to pin A, which has the servo, and we want to go to 170 degrees. So really, really simple and easy. You can play around with all different types of inputs. Instead of on shake, you could do on loud sound, for example, so that you can clap and make this thing kind of turn the head or whatever. Really easy and really quick to kind of get in here and start playing with it. So we can just kind of explain that here in text format. Looking real quick at the circuit diagram, it's just 3 connections. Again, no soldering required. If you have Alligator Clips with those male connectors, you can plug them directly into the female connectors of the servo, which is really nice. And then to power the thing, we have a 3 AAA battery pack, which powers the Circuit Playground and neopixels and all that stuff. Next page talks about the cardboard template. So we have different file formats. So this page over here, which you see in the photo, that is available as a PDF, which is sort of like your standard document, vector document for printing on all sorts of different printers. We also have the SVG, so you can use a laser cutter if you want to cut this out of like the cardboard itself. You can just do that. We also have a flat pack, which is what I just talked about actually, and then the Fusion 360 Archive, which is the 3D CAD model with user parameters, so you can modify it. Let's say you have a different thickness material, you can change that, and all like the little slots and tabs will automatically update, which is really cool. So we have 3 different choices of files to play with, depending on what you want to do. So that's cool. And then we kind of just talk about how you can cut the parts. You can optionally use one of those vinyl cutters, like the Qriket or the Silhouette. These are sort of CNC machines that have like a drag knife on them, and they can cut out designs, preferably in vector graphics. So that's an option. We're hoping that people just cut it out with standard scissors, and then just kind of cut it out in freehand. Because that's kind of what I did. Because the CRICKIT that we had at the time couldn't cut the cardboard. It's really thick. So what I was doing was cutting out the template out of sort of a cardstock or a chipboard, and that way I can just overlay those thicker pieces on top of the cardboard and then cut them out. There you go. And then there's just a little bit of a kind of an exploding wireframe of the pieces snapping together, so you know which piece goes where. Pretty straightforward. As far as the assembly goes, pretty straightforward as well. Cutting along the grain, making sure that when you make your slits and stuff, you want to make it so that the cordations are are going along the length of the part. Yeah. And mounting holes, a couple different ways you can make mounting holes. You can use an owl, or you can use a drill bit if you really want, or you can just kind of punch them out using a small diameter hole punch. We got these brass screws in the shop, but I also linked to this sort of variety pack that I got from Amazon, which has a wide assortment of different M3 sized brass standoffs. It comes with the jam nuts, or the hex nuts, and some screws as well. So those are all linked for you. I'd recommend getting the variety pack. Maybe we'll stock that, because I like the different variety of them.
They actually both work pretty much the same.
They work the same, yeah.
So it's just, really just a preference on how you want to mount these.
Yeah.
Maybe there's an instance where this will work better, but for this case, either one can be used.
Yeah.
So, and then moving on to mounting the servo.
Yeah, so mounting the servo comes with mounting screws, so I just used those and stuck it onto the cardboard pieces there via the tabs. Alligator clips connect to the circuit playground, and there's a cutout on the bottom of the circuit playground, well, there's a bottom of the piece, so you can route the wires through. And then just connect those to your micro servo. Oh. And then you can plug in the battery and slide it through the cutout there. So that's pretty simple. As far as next steps, we talk about just kind of different options for mounting different things onto the servo horn, and just kind of some ideas and stuff. So that's pretty much the guide. Yep.
Very nice way to set up a customized cardboard holder for any of your papercraft projects. Kirby was saying, surprised we didn't use the Adafruit boxes, but we actually ran out. We should not have prototyped on those boxes, but those will work just fine. Yeah. They are, what is it, 0.8 millimeters thick? They're like the E-flute?
They're a little bit, I think they're like 1.6. Okay. This one's a 2.8. But they'll both work.
So they should either work by hand cutting or with a paper cutter.
Yeah, we need to ask the CS team for just a bunch of Adafruit boxes.
Yeah, I think the easiest thing, the chipboard that we're going to be talking about later, they actually come in a very nice black color. They're going to be testing out just to make it look like we've been using nothing but Ada boxes.
Oh, that's fun. Yeah.
But yes, we will switch over to black.
Okay, cool. All right, well, let's take a look at Pedro's guide for, this was actually released on Tuesday. Do you want to tell us a little bit about this one?
Yeah, so PT had a really good idea on making animated logos with the Playground Express. And one of the logos he wanted to animate was the Hackaday logo. And when he said that he wanted spinning, the first thing that came to mind was, how do I actually make this thing float? And one of the coolest things that we learned from using the Nintendo Labo, the piano key little build, was this, one of the, I don't even know what button it is. I think it's like one of the,
yeah, I forget.
What's it called? The oscillator? Sorry, I don't know too much about the audio
keys?
stuff. Yeah, one of the keys, yeah, that like changes, like does modular something.
Okay.
But that design for that was excellent for making a pole that could rise out of the box that's holding the Circuit Playground, the battery, and the wires, extend outwards and mount the motor right on top of that, and we're able to have a nice little floating logo for that. So super simple. We're just using a continuous micro servo for this, and inside the MakeCode I just have it rotating clockwise and counterclockwise, and then when you hold down on the A button it'll shut off. Super simple little project that definitely it's a nice way to animate a logo, which I never thought about would be a nice, pretty simple thing to do. Now, 3D printing this would, take quite a while just because of all the flat layers that you would require to mount this.
Yeah.
So paper, actually chipboard is what I'm using on this, and I'm using something that's a little bit thicker. It's a 1.6 mil chipboard. I think they label it as like either 40 point or heavyweight chipboard. And I'm using 3 layers of this for the skull, and that's what's actually just press fitting the servo mount on here. So I actually could go in here and
wedge it out. It's got
wedge
a nice
it out.
Tolerance.
Yeah. So this is a really nice way, and I know that people who do like laser cutting, they know this right away, that you can just layer things, stack them on top to create a thickness that could hold whatever that you are mounting.
Right. A lot of the Raspberry Pi Zero cases, for example, are just layered up, like the rainbow case from Paper Money.
Exactly. And then we're just using 2 of them to create the back for the wrenches. And then just using white and black cardstock to layered on top of each other to create that. And then we're using a customized version of your Circuit Playground Express box. So it's a nice little foldable box. Yeah. So I just show the inside of this. Nice little tabs.
Tab. It has actually sort of a locking slit. For that tab.
So these
so
little right here, and then there's a little slit that allows it to go through and then lock into place. And then we're using a nice little piece of cardboard right here to act as a stabilizer, so the pole doesn't go back and forth. And inside there you can see the nice little battery. AAA will fit in there as well. It'll give you a little bit more weight to hold everything down, but you honestly don't need it since the weight of the wrenches and the Circuit Playground actually balances it out, so you're able to stand it up. And it's a super cool little way to make a animated logo for whatever business, or if you're having a maker fair at your booth or whatever, whatnot. Whoop, out of the way there.
Yeah, maybe I like that. So if you're going to your next con or convention, any sort of like display, you can create add a little bit of motion to your signage. Right?
And of course, you can go a little bit more interactive with this and use the light sensor on here, or have it activated by sound, temperature.
Right.
You can take a pic of any of those really easy ways to interact with this. And if you take a look at the MakeCode, I have a whole guide on this as well, since we actually didn't make a step-by-step on the last 2 projects on how to actually assemble this box.
Right.
So I'm just showing the parts here. If you jump over to...
Also, just a quick note, the 2 types of chipboard that we're using are linked here. There's so many different ones to get. So definitely get these, because we've tested them. They're a good supplier. They're available on Amazon, so you can get them all over the place.
So actually I want to stop there at a 0.8 chipboard is what we're using for the box. So it's a little bit more thinner, still has some flexibility in it, and it has a nice rigidity while still being thin, so you're able to maintain the box shape. And then the chipboard is actually used as the backing. For a lot of our projects, that's what we're going to use, the thicker 1.6 mil chipboard for that, just because it's really rigid and it's not going to bend on you. And it's pretty close to not really close to the cardboard, that you'll get shipped. It's a little bit more thicker, but it is a nice substitute for that once you run out of all that cardboard.
Yeah, and we'll probably talk about which one can be cut on which machines, we're going to do a whole guide on using a machine like the Qriket or the Silhouette type machines to cut these types of materials. Some of them are easier than others.
Yeah, and then if you scroll down, you'll see some of the parts you're going to need for this. Nice little micro continuous rotation servo, which is, I think, the first time we've used it in a project.
Yeah, they're pretty sweet. And
then, of course, the Alligator Clip to mail jumper, which we'll show you how to make your own, since we seem to be out of stock.
Yeah.
So circuit diagram, super easy. We're just hooking up signal, which is the what are these? The yellow or the orange. It's going to go into A1, and then ground is black, and then V out is red.
Yeah.
So it's always going to be like that.
Down there, yeah. My guide says pretty much the same exact thing.
Yeah. So the continuous and the regular microservo, the colors of the wires are the same for that. And then inside the MakeCode, you can see that I'm just having the B button is going to rotate it counterclockwise, and A is going to rotate it clockwise. Then the long push for A will
stop it.
Sweet. Super easy. Again, MakeCode to the rescue here, because
it's great.
setting something up, something like this.
Yeah,
I would not know how to do this inside of regular CircuitPython.
CircuitPython or Arduino. Yeah, sweet.
Especially the long press on the A.
Yeah.
So I was able to just drag these blocks around and sort of connect them until they were doing the action that I wanted.
Yeah, for the most part, I think something as simple as a button input is really easy to kind of do. Yeah.
So definitely really helpful for that. And of course, you can go in there. As you can see, it's an embedded drag and drop. So you can just edit this, like I was saying earlier, to have it activate when you have light or sound or temperature or any of the other sensors that are on board.
You said it. All right, and then as far as cutting goes, we have the Hackaday what did you call it? Pre-made logo or something?
Yeah, so the SVG...
You had to make it for cutting.
Yeah, so we're going to make a whole other guide on how to actually set up all your compound paths, your clipping layers for having all your artwork that's ready to bring into the whatever cutter program that you're using, just so that everything is nice and set up.
That's going to be more for like sort of people that know how to work vector graphics software like Inkscape or Illustrator. But it's really important to know, just to kind of know about it and be like, if you wanted to set up your own artwork. Or someone else's artwork like we did here.
Yeah, you do have to do a lot of compound path.
Or just thinking about layering and
how to actually cut this too, so you're not cutting all these tiny little bits out.
Right, because you could have cut it in a way where the eyes are manually positioned and glued onto a white surface. But if you cut it away from the white and just reveal the backing of the black, you don't even have to worry about placement. You get perfect placement when you think about what you're going to cut as opposed to what you're going to add.
Exactly, yeah. So all of the SVG files that we're releasing, they're all nicely layered and named, so you can go in there and see what is going to be, you know, the backing for the cardstock or the front part of it, and the chipboard. So everything is nicely layered. You can go in there inside of
SVG. Yeah, they retain groups and names.
Exactly, yeah. One thing that it will not look at is any guides. So if you have any like guides set up, alignments set up, you just have to make sure that those are all deleted before you save that out and import it into your cutting program. Yeah, it'll think it's a clipping path and it's not supported.
Right, okay.
And then we also give away the files for the customized version of the CPX
foldable
box
and the foldable stem, which kind of elevates the whole thing.
So again, I want to point out that this is a modified version of the Nintendo Labo latch switch that was on the piano. So there's a lot of really good design box ideas inside that. I think we linked to it in one of the blog posts where Nintendo has uploaded all of the template files for that. And it's a really nice inspiration to go through there and look at all of how they were creating all the boxes. Of course, go out and buy the box so you can actually experience putting one of these together, because it'll give you more ideas on how to actually mount papercraft boxes. They all don't have to be, you know, like in a just thrown into a box. It can be nicely turned into a nice design.
Totally, man. Yeah.
So definitely check those out. You have the pole and the foldable box design for that.
So separate SVGs, so you can use them as you will.
And again, you don't have to use a cutter. These should work just fine with
paper cuts, paper templates,
with scissors.
Sweet.
Moving on to assembly of this, you do want to make sure that you actually add a cut score onto this. The Qriket maker that we used all this on does have the ability to score, but it doesn't have the ability to cut score. But it'll at least give you a nice marking of where to add your cut score. So just use a ruler so you can add those in. You want to cut about halfway into the chipboard material and then add a nice sharp fold on the other side. Otherwise, it will not keep its shape if you don't add that really nice sharp fold in there, the crease in there. And you want to do the same thing with the box. And then, as I was saying before, the head part is printed with the thicker chipboard, layered and stacked to make the servo mount for that.
It's pretty clever.
The layers for the wrench, the crossed wrench artwork for that, has a nice little circle in the middle, so you can gauge where the center of that is going to be. And I'm just using the circular servo horn that is actually included with the continuous servo. I would pick up the continuous servo just for all of the nice little horns that it comes with. I thought we actually sold that separately as an accessory, like add-on, but they actually only come with the continuous servo, I believe. Okay. But they come with quite a bit of them. I don't show them all here, but this circular one turned out to be really good for guessing where the center of your object that's going to be spinning is.
Sweet, okay.
And then assembling the Circuit Playground box. I realized I did not show how to do this in the previous project, so I added that here. We're probably going to move this on to its own, into the guide on showing how to add the papercraft, like the main papercraft guide for this. Okay. But here it is. Until then, a nice simple setup using the pretty close to the exact same the threading standoffs that we're using in your project.
Yeah, M3. M3 all the way.
So we just stick the screws from the bottom, have the standoffs on top, screw those in, and then another additional M3s on top of the Circuit Playground. And you want to line that up so the port opening for the JST is aligned with the cutaway on the box there. Yep. And then all the wires can thread underneath the Circuit Playground. We'll be threading the jumper to Alligator Clip, the servo, and the battery. We'll go into the JST cutaway there. I'll fold that up and then connect all of the Alligator clips. And then once all that is connected and powered up, you can go ahead and insert the pole. And then just want to make sure that the little holder, I don't know what to call it, like the stabilizer that it slips through for the bottom piece to keep it nice and straight, that all the wires are away from there. And then we can simply mount our servo mount to the top of the pole. We're just using the M2 by 9mm screws that the servo includes. So it's a nice little, again, a nice thing to get because it does come with all those screws as well. Right. And it comes with more than you're going to need, so you can definitely use those for more projects.
Oh, cool. Excellent.
And that's pretty much it. Oh, I have some scaling issues there with my with my animated GIF there.
All right, so you might be wondering, well, what if I don't have these alligator clips with male jumper?
So these are super cool because you're able to go from alligator right into the female servo connections that are on all of the servos here. So we did, I think we're using all these in the AdaBox 08. This is why we're probably sold out. And either that or they were just that popular. But we do have a lot of these alligator to alligator clips hanging around, and we also have these regular male-to-male jumper cables hanging around. So it's pretty easy to actually hook these up. So what you want to do is open this mouth up, and I think the easiest way to do that is just like have it grab on something so you can slip this off. That'll make it short enough. Can you zoom in there? So you can remove that right here. And the only thing that's holding these two together are these little metal tabs on the side. So you actually don't need to unsolder anything.
No soldering required here.
Yeah, so you can go in there and simply lift these tabs off. Or for dramatic effect, see if I can rip it off. Yeah, just rip these off.
Does the wires that remain? Yeah, just a little bit remains in there. A little bit
remains in there, and then you can go in there with either some tweezers to get some footing in between the tabs. Hopefully I don't stab myself.
No.
You
want to be careful. Yeah, you're fair.
You can just lift these tabs like so.
This is a lot like crimping. Well, it is crimping without the crimping tool.
I can do this live demo, folks. Should have did this ahead of time. So I can get that in there.
You can show your technique here. So these are flat pliers. They don't have any teeth on them or anything, but they're good for these type of things.
So I got one of those tabs flipped up. Let's see if I can get to the other one.
Don't break our tweezers.
One thing I'm more concerned about is, of course, stabbing myself.
Yeah, me too. You do not have your tetanus shot yet.
Obviously, what makes this more difficult is that I don't have this right in front of my face.
Yeah, because
trying to frame it up to the camera.
Be over the frame. That's the hardest part about filming anything is like your head.
Oh my god,
in the frame.
Yep. Especially for like solder shots.
Yep. So just a quick recap. We went over 2 guides, and now we're just going to take a look at a DIY alligator to male jumper cable, which can be very useful for connecting components like micro servos to
we was here
the alligator to Circuit Playground Express.
Yeah, it's always one of the bottlenecks we hear when we
like
talking about education or
solder.
workshops is having to solder everything up. And that's actually what takes the most time.
That and installing the Arduino IDE.
Oh my god, yeah. So hopefully, if you are doing a workshop, you do this ahead of time. So
or
the other part,
have pre-made ones.
Yeah. So the other part is actually taking the plastic housing off of the jumper cable. So the way to do that is to push the pin forward so you can get to this little latch.
Yeah, push it up so it's not latching onto the little metal piece.
So
and that'll let you free it out.
Right there. There's the latch.
Yeah.
So once that is lifted, you can pull the housing right off, and you can reveal the male part of this. This should work with the female as well. It is small enough to actually fit between the 2 tabs right here. All you want to do is push that in through
down. There you go.
Between the 2 tabs like that.
Oh, there you go.
You can see it's already gripping on there, right near the ends of that.
And then crimp it.
And then just crimp each tab. Like so. And there you go. We have a
sweet
alligator to male jumper.
Now, how about putting this
putting
back on?
Yeah, so to put the sheathing back on, you want to again grab onto something. Like
it's a little tricky to work with. Like for like 5-year-old, it's kind of hard to work with these. But hey.
Push that
so
through.
Using something to kind of keep the jaws open
Mm-hmm.
is really helpful because it can be a little slippery to fit it back in the other way.
Yeah, I should put it in the other way first, but there you go. It should go through.
The hardest part right here, folks.
So,
yeah, put the alligator sheathing on first. Yeah, good idea.
Yeah,
and then crimp it. Yeah,
that's definitely.
We'll do that.
Especially
we should do like a quick,
right here,
like a 1 minute, DIY with a quick edited video or something.
Yeah.
That'd be cool. But we've both seen this technique done a lot of different places. John Park actually made his own custom, like right-angled jumper female cables, which you can do as well. I think I did that for like the Pip-Boy project back a while ago.
There you go.
But yeah, making your own cables is definitely nice, and sometimes you don't need solder or solder.
And this is ready to plug into a servo or any other female component.
Breadboard, for example. So you wanted to breadboard something.
Oh, yeah.
There you go.
There you
Excellent.
go.
Great. It's a good tip.
So that is how you can easily, should be a lot more easier off camera when you're not framing up a shot.
Right, and you can actually look over it.
Mm-hmm.
All right, so yeah, if you want to pick up male alligator clips, female, yeah. If you want to pick up regular alligator clips, we have those in the shop, different lengths, different colors. It's good to have these on hand. Paper craft will get you 10% off if you want to pick up some. Sweet.
And if you just want to wait for the already made jumpers, you can go ahead and insert your email for notifications on when they'll be back in stock.
Awesome. All right.
Moving on to this week's...
What are you prototyping?
What are we prototyping?
All right. So real quick, I want to show you what's kind of working in the background. We have some more paper crafts that we're working on. So this is going to be a part of next week's project, which is just going to be all of the Circuit Playground. Most of the Circuit Playground characters are going to be sort of templatedized for a papercraft version of these characters. So this is Minerva, who's our mascot for MakeCode. So taking artwork from Bruce Yan, who designed all of our Circuit Playground characters, and this is Minerva. So she's actually just layered up of different pieces of cardstock. So you have purple, white, blue, a darker blue over here, and this pink. And then in the back here we have a nice thick backing which is that chipboard that we've been talking about. And then her body is pretty much the same stuff, except a little bit less colors. What's interesting though is that this texture here is just a cutaway that reveals this sort of purple layer that's sandwiched in between this blue, this dark blue and this light blue. So you get this really nice effect. This just really showcases like the precision and the detail you can get out of one of these vinyl cutters. The vinyl cutter we're using is the Qriket. They come in different models. Most of them will be able to cut this sort of medium weight chipboard. So it's a lot of fun. There's a little bit of this was kind of like the limits, I think, of the machine, is where you're making these small little details. It's kind of hard to see it because the camera doesn't want to focus, but they came out pretty good for the most part. So just working through the artwork and making it so it's a little bit easier to assemble for people is kind of like the goal here, to release all of these craft characters in a way where they're a little bit more easier to assemble. So we're working with that. We're also working on just kind of making type for sort of building up different assets for photography and different banners and that sort of stuff. So this is the MakeCode typeface, and this is kind of neat. This is combining 3D printing and papercraft. So this top layer here is actually all cut using the Qriket and different types of scrapbook paper. So this one has like this texture here that's kind of like a cosmic space with like clouds and little bits of stars and this nice little color. And then the backing here is just chipboard, which is like the outline. And then this extrusion here is just a shell that kind of creates the effect that this thing has like been extruded. And it looks like one piece at certain angles, but it's actually two pieces. As you can see here, this is the gloss here that was printed on the printer, and then this is that chipboard. So that's cool. We got another one here. This is the MakeCode logo, which is like a puzzle piece. And what you could do here is like with these sort of shapes where they're cutouts, you can use a backing like paper, just regular office paper, to create this kind of light diffusion. So if I wanted to diffuse some lights, I could plug this in, for example. It might be a little bit overblown, but you know, you can kind of put that there and make this like kind of glowing logo, so it's neat. All with Circuit Playground. Nice hollow shell, prints out fairly quick, and this cuts out even quicker. So if you're trying to kind of make the signage that's a little bit extrusion, you can add 3D printed stuff to make your paper crafts a little bit more depth to them. Sweet, so that's kind of what we're prototyping, more paper craft stuff. That'll be next week's project, is all the characters that are a part of the Circuit Playground show. Excuse me. All right, so now let's take a look at MakeCode and Qriket. So this is the Qriket board. I almost thought this fell apart. So the Qriket board, we got it a couple days ago, and what you can do with the Qriket board is just do a lot of motor control. You can control several things at once. Be sure to check out our playlist of videos to showcase all the projects that PT is working on. And what I want to do is I want to show you guys how a first look at using MakeCode with the Qriket board. So let's go ahead and jump over to the website over here. So if you use this link right here, I have it in the description, makecode.adafruit.com/beta#editor. So if you go there, you will have access to the new stuff. So if you go over here into the Advanced tab, you'll get a couple of drop downs here. Under Extensions, you want to click on that, and you'll see that we have, well, Qriket's already there. That's great. Well, if you just search for Qriket, if it doesn't show up, search for Qriket, hit enter, and there's the extension, so you can install that. So that installs the plugin, and then you'll see here in between the music and the input blocks, you have a Qriket block. So now you can do things like you can run the motor. So let's say I have a loop here, or maybe I want to do an input. Maybe I want to say on button A, I want to run this motor, motor number 1 or 2, and then you can say what speed you want. Like, do you want 50% speed or lower than that, or do you want full speed? You can do that. And then let's say if you wanted to stop it, you could do on button A, long click, stop the motor. Over here under the motor control, you can say stop motor, and you can specify which motor. For this example, it's motor 1. And then you can quickly create this sort of on and off toggle switch for a motor. So that's just one really quick example. I'm kind of flying through it right now because of the timing, but I definitely encourage you to check it out for yourself. If you do have a Qriket board and you're looking for what to do with it, check out MakeCode and install your Qriket extension so you can start playing around with different things. So I kind of have the same thing set up here. So if I hit button B, or maybe it's button A, button B, I get a little bit of NeoPixel action, and then this one starts running. And then if I hit the other one, the NeoPixel happens, and then this one starts running. So they're both running right now. Right, they're both rotating at 50% speed. If I want to stop them both, I just hold down both buttons at the same time for 3 seconds, let go, and they both stop. Very, very simple example, but it showcases what's coming, or what is available at least for the Qriket and using Microsoft's MakeCode. So there are more things happening. This is a super beta. It literally got released like yesterday. So it's really nice to see how quick the team is working on it, but there are other things too. Qriket Tank, that wasn't there yesterday. I don't know what that is. Make a robot drive forward, backwards, turn, or stop.
Wow.
Set motor inverted if you want to invert the rotation. If you want to do Qriket digital write signal, you can do low or high. You can read from a pin as well. So this is all stuff that's happening like on the daily. So check it out. I encourage you to play with it, and we'll put together some sort of, projects and stuff as the development happens with it.
Yeah.
So this is just a really quick early look at the Qriket and where's our MakeCode logo? And oh, you put it away. And MakeCode. We don't have a graphic. We just have actual.
Yeah, we're just gonna start doing all our motion graphics with actual cutouts.
Yeah, it's very cool. Yes, John likes it. And
there
Kirby
is also I don't know where it is now. Maybe they took it out to work on it, but they also showed off a plotter right inside of MakeCode as well, so you can take a look at what these values sensors are reading. I don't remember what it is. Maybe
it's certain things. Yeah, I don't think it's supported for Qriket yet, but hey, it's being worked on. So that's really cool. So definitely encourage you to check it out. We got links in the description.
Check out daily because it looks like there's always updates. Very cool.
Awesome. Don't forget Qriket. There's a full learning guide. I mean, there's a full playlist of different projects that PT and team has been working on. We're up to 20 projects, and all of the code that goes with those projects are available right now on GitHub. So if you go to the link in the description, you can see all the code that's available. I really want to remake the bubble machine. That looks really cool. So you can play around with that. These are all CircuitPython, by the way. And then real quick, this is one of the first projects that PT put together, which is a Trash Panda. And shout out to Dano, who put together the guide for the Trash Panda. So this is one of the first guides using Qriket and CircuitPython, right? Or is it? Yeah, just CircuitPython. Awesome. I also want to give a shout out to Dano. If you don't follow him on the socials, check him out on Instagram. He has a really great look at robotics and some of the behind the scenes at the Adafruit offices. This is what he's working on right now, which is a walking robot made out of cardboard with just 2 servos, I want to say. Yeah, 2 servos.
So yeah.
Yeah, very cute and yeah, make a robot friend. So there you go. Very cool stuff.
Yeah, definitely check him out.
He's been working on a lot of great stuff.
Scenes in the office.
Yeah, here's some gears with straws and stuff using just Circuit Playground. I wonder if it's MakeCode. I'm not sure. Is the thing running in the background? No, it's not. Sorry.
It's the audio from
So Dana Wall, check him out on Instagram. I got a link. Here's his StumbleBot. Is it stumbling or is it's walking now? It was a StumbleBot, but then it evolved to an actual walking bot. Very, very cool. It has
evolved.
Yeah, he's evolved him. That's awesome.
So definitely check him out.
Yeah, check him out.
For all the behind the scenes in the office. Take a look at all the cool testers that are coming up.
And
of course, all the robots.
And cats.
Kitty cats.
Very cute cats. And laser cut stuff. And 3D printing stuff.
Everything going on in the office.
Yeah. New York. Sweet. All right. Don't forget, coupon code. Papercraft. Let me regroup here. Okay, cool. Oh, what are we prototyping, aren't we? All right. Over the weekend, I put together a little case for the ItsyBitsy board and this feather wing, which is called the Joy feather wing. Joy feather wing is one of the first feather boards that has the Seesaw coprocessor for doing I²C. So you get this cool joystick here and a couple buttons, very, very small buttons. this enclosure is a two-piece snap fit together. You have access to the micro USB over here. You have access for wire breakouts over here. And this just snap opens like that. One of the cool things is that there's no mounting screws. And what you can do with no mounting screws is have it so that it's easier to mount. So, there we go. So what you can do is you can remove this board. It's not wired yet, but you can remove the board, and there's a little ledge here that kind of holds the board up. So there's no need to use screws to mount this in place. You notice that the ItsyBitsy doesn't have any mounting holes for screws, so we're able to just press fit it into these little walls here that keep it in place. So a really interesting way to kind of make an enclosure that doesn't require any mounting holes. So ItsyBitsy board just got a guide released on the Learn site. This just snap fits in right there. And we also have a link for you guys in the description of this video if you want to download this case. Or if you want to just download, look at my cap came off. Or if you just want to download the CAD file that has the pinouts and the buttons and all that modeled in CAD. So you can put that together if you want. What that project's going to be for is kind of secret. We'll talk about it some other time. But that's just what I wanted to come up with. So if you go to learn.adafruit.com, you can see we have an ItsyBitsy guide. So that's out. And we have a couple projects already with the ItsyBitsy M0, which runs CircuitPython. It could also do Arduino. And it has tons of pinouts. It's very low cost. One of our most affordable M0 boards that can do CircuitPython. It has a lot of flash on it. It actually ships with like sound effects and cap touch and all these things already working. It has a dot star LED on the board. All this in this tiny little package, ItsyBitsy. So if you want to do some CAD work with it, you can get the file here. It's all modular and in pieces and components, so you can use it in any different type of project. Whether it's the ItsyBitsy board or the actual Joy feather wing, you can get it. And it has all the pinouts too, so you know exactly where the pins are going to go, which is nice. And most of the components are on there, like the status LED and everything. So that's really cool. So check it out. If you want to pick up a feather, the Joy feather is in stock, so you can pick that up. We got some demo code to do this type of thing, and we're working on more projects with it.
Yes, it is actually an upcoming project, so definitely pick one up so you can have it. If you want to build a nice little control.
Yeah, maybe you want to control something. Maybe you want to control something with it. Cool. All right. So moving along. I think one of the last things we're going to showcase is
jumping into this week's makes.
Already,
community makes.
Already so fast. Wow, we kind of ran through it. Pretty cool. Yeah. So this week I want to shout out to education maker extraordinaire Colleen Graves. I tweeted to her, like, was it over the weekend or last weekend, about your waving makey robot project. I was like interested to see what her students would come up with, and she had her daughter come up with this little quick project using MakeCode and Circuit Playground Express. So that's awesome. So it's a little robot that waves his hand, and he's powered by Circuit Playground Express and MakeCode.
This is awesome.
Yeah, look at it's really fun. So one of the things Colleen was saying is that like it was really easy to get started with it, and it was really nice for her daughter to just kind of make the robot instead of like cutting it out with a CRICKIT, like because didn't have chipboard, I guess, to kind of put together the rigidity of it. So
no, it's definitely
cardboard is great. This is what we want. We encourage to kind of make it your own thing. So yeah, that's really great.
Our polished thing that we release out there is really just to inspire you to take that and make it your own.
Yeah, that's it. Sweet. So shout out to Colleen, and if you want to follow her adventures in teaching and making, you can check her out on Twitter and Instagram. She's also an author of a couple books. Makey Projects for the Evil Genius is her latest one, so you can check that out. Very, very cool. Maybe we'll stock it in the shop.
Super cool.
Oh my gosh, look at this one. And she just shares a lot of other awesome, interesting projects too in the sort of education maker community, which I'm super happy and thrilled to be helping come out with projects for.
Very cool.
Great.
Very cool inspiration.
Great stuff, Colleen. Thank you for sharing. Well, that's pretty much what we wanted to cover in the show. We can do a little Q&A if you guys want, but for the most part, that's what we got going on. Next week, we'll be coming out with the paper crafting templates so that folks can make their own, whether they want to cut it out by hand or have a robot cut it for them. You still need to assemble them with glue. So that's always cool.
Just a couple comments. Yanni's saying that, yeah, this is a really good way to, Stuff with Kirby is saying that this solves the issue that you don't need to use a stencil font for 3D printing, cutting everything out of the paper.
Yeah, I really like that idea of combining not laser cut. Well, I guess it could be laser cut. Just combining different mediums because you get such a great surface finish with a vinyl cutter, and you don't get that much of a good surface finish, at least without too much effort. You could spend days sanding, but maybe you don't have to if you use this paper stuff.
John K is saying that the Make logo looks pretty cool.
Yeah,
would like to make one, add LEDs inside to light it up.
Absolutely, that's what it's ready for. I just need to get on that part. But yep, really nice. Yeah.
Yep, John K is also saying that, yep, that's exactly how he makes his jumper to Alligator. Only thing missing is heat shrink to insulate it along with solder to add that strength on there.
Solder, yeah. If you have solder, use it. So anything in the YouTube or in the Facebook?
Yes, on Facebook, Mike Dole.
Which model
check that out.
Qriket? Qriket.
Yes, we are using the Maker specifically for the knife blade, which lets you cut the cardboard or the thicker material. You can also cut basswood or balsa.
Yeah, so just real quick, I'm going to show a couple of little clips of the process of working with one of these machines. It's pretty straightforward and easy. This is the Air Explorer 2, which is the first model that we got. It was sort of their latest model.
It's their cheapest model.
Yeah, okay, cool.
And you are able to cut the 0.8 millimeter chipboard, which is what we're using for all of the enclosures.
Foldable boxes.
Foldable boxes. You could actually just stack them. You could stack a bunch of these, save on having to get the Maker version of this, but it works just fine. Yeah. It'll do, I believe, 3 passes for the cuts.
That's right. Using the max pressure of 350, I think is the vibe. That's specific to Qriket. Yeah.
And that works just fine with the fine point blade that it comes with.
Right. And here's Pedro putting together the Hackaday
here. I believe so. Yeah.
So his box template's pretty similar, just a little bit of a different spot.
And here I'm just showing that you do really want to make sure that you use that cut score in all of the boxes. Otherwise, they're not going to keep their shape. And
so this is the Maker version, which has a tool head, an adaptive tool head that just gives you like 10 times more pressure than the Air Explorer model. So you can cut
up
like
to 2.3 millimeters deep with that blade, I believe.
Okay, so pretty
based on their profiles, yeah.
Okay. And of course you can do scoring and stuff with the pen plotting.
Both of these can do that.
Yes, both of them can.
So you can draw to mark where, I use it for seeing where the center point was.
Right.
And here I'm just showing layering the thicker chipboard that I cut out with the knife blade and how that is able to just mount the servo on there with the card stock right on top of that. That's a nice little way to add, attach your servo to whatever artwork you're working on.
That's right. And then for making Minerva, the Qriket software will take colored vector artwork and separate them into individual color mats so that you can cut out a group of shapes that are one color and then just kind of keep doing that process where you take off the stock and then put on a new colored sheet, cut that out, rinse, repeat or whatever. And there's the layered, pieces that come together to make this really vivid colored character. And there's all the characters we're going to come out with. So that's Qriket, Minerva, Blinka, and Adabot. And
if you want to see the finished signage for the Circuit Playground that we're cutting here, definitely tune in to all the shows later tonight. We did ship some of these over to the office. So
using holographic vinyl, this is pretty dope.
And I don't think I showed the actual finished one, but it looks pretty cool.
You check my Instagram, I got some cool
check it out on all of the
paper.
Check it out on all the shows tonight. She'll have those think UPS probably got there just now.
Yep.
So if you check those out.
And the last clip I got for you is just, so our supplier for filament, they're called Melt Ink. They have some really nice boxes. And so what I took one of the boxes and I figured I'd cut it apart. If you take out the sides, you get these 2 front and back panels that are really nice, and they have like these kind of sweet looking graphics and type on it. So you can use boxes from everywhere. So this is from our filament supplier, Melt Ink. Again, I really like their little their type and stuff. So I used that box to come up with a couple of the pieces for this week's project. So you see here, I'm just laying out the pieces, making sure that it all fits on this sort of little puzzle thing, and using a micro pen to outline it, so it's a little bit more defined than something like a pencil. So just kind of laying it out, outlining it, and just doing that over and over again. I like to keep them kind of tight, so I use the most pieces.
Exactly.
It seemed like it was kind of a small piece, but this cardboard's nice. It's kind of the same 2.6 millimeter thick cardboard that you see from Amazon and other shipping places. It's kind of standard, at least here in the States. And then just kind of reciprocating, the knife to cut out these little slots and cutouts. But most of it is hand cut. All of it's hand cut.
For this project,
for this project, because I just couldn't cut this cardboard yet. On the Qriket.
Yeah. It's a good thing to mention too.
Yeah. So takes a little bit, but it's good. It's good practice.
And it works really well for these box enclosures.
Yeah, it's pretty good. All right, that's pretty much it. So if you guys want to pick up anything in the shop, support Adafruit and your Make Your Habits. You got a great team over there prepping all the Qriket manufacturing.
Lots of prepping going on right now.
Kitting for all the Ada boxes about to drop.
Yep, sampling all the parts. Going really good for that.
Yeah, it's a great time.
Real quick comment from John K saying that he's using hairspray to glue all the layers together. Says he works really well.
I should do that.
So definitely have to try that.
The glue stick. And
oh my god, yeah.
Great tip. I gotta do that.
I actually had to swap out one of the parts when I was sending it to the office because I got some glue stick, like the weight, dried up glue that it leaves behind.
Flaky.
So swap that out. That's a nice tip there.
Good trick. All right. Well, tomorrow, let's do the real rundown. Don't forget, tonight we got a show and tell. You gotta do it. 7:30 p.m. You want to come in, say hi, show
we'll
what you're
be
working
there,
on.
showing off our stuff,
say what's up.
Along with everybody else. Everybody around the world comes in, shows off the really cool projects they're working on. So definitely check that out.
Last week was great. It's great robots.
It's always great, yeah. Lots of cool robots.
Ask Engineer is at 8 p.m. or shortly after. Still tonight.
Whole hour of Lamar and Phil talking about all of the cool things happening with projects, products, and all the things around in the maker world.
Last week we had great guests. Tomorrow, Thursday at 4 p.m. Don't forget John Park is going to show you how to build some stuff.
Yes.
Mostly out of cardboard. No, he does everything.
Yep. Every single type of material.
Yeah, it's great stuff.
Definitely tune in for that. And another coupon code as well. If
you miss it today, you're going to get it tomorrow.
Yeah, because all of the new products get stocked or go up online at night. And if you don't get a chance to get that, you still have one more chance to use that coupon code next day. So definitely check that out for that.
And that's going to be it for tonight, for today. For now. We still got to do stuff tonight.
Yeah, go check out MakeCode, play with those drag and drop blocks, make some cool interactive projects. And
don't forget to make a great day.
Bye.
I'm tired. Thanks, guys. We'll see you next week.
See you guys.
Adios.